Pessoal, bom dia. Bom dia. Okay, good to see you all here. Thanks for keeping the energy. We're almost there with the Campus Expert Summit. It's been a hectic 2 weeks. A lot of things to digest, but hopefully you're gonna get the most out of it all. And I think we couldn't be ending this 2 weeks with a better topic this morning, and then in the afternoon we're gonna also have another pretty cool topic to deal with. But this morning we're gonna talk about something that is truly interesting for us Brazilians, which is understanding how can we build better apps focused on emerging markets. Emerging markets at Google, we usually call them next billion users markets, because that's our belief that the next billion users that will come online won't necessarily be from the US or other developed countries such as Europe, but from other places such as Brazil, India, Southeast Asia, and Africa. So this is a great opportunity to understand from Onome, who already gave a talk on machine learning, but her perspective on how we should be thinking about developing apps for that particular audience. So I love these titles in which you have like just 5 things to remember. So it's pretty easy. You don't have to take notes of everything, just the 5. And I'm pretty excited to understand more her perspective about how we should be doing those things and taking our businesses to the next billion user markets and taking advantage of that opportunity. With no further ado, please welcome Onome on stage. Thank you.
Hi, everyone. Thanks, like Andre said, for joining us and sticking through this past 2 weeks. So my name is Onome Ofoman, and I'm a software engineer on the search team at Google in New York City. So most of you probably already know that about me. But what I wanted to talk about today is how you can build apps for the next billion users. So 3 things I want to cover. First of all, why next billion users? Why are they called that? And then secondly, why should you guys care about them? And then the third thing, just to share some tips and best practices on how to actually develop apps for this segment of the world. Just a second, I have to log in. All right, so 1 billion, that's a pretty huge number. Where does it come from? So 1 billion is actually the number of new activated devices since 2014 up till today. So if we go back to the history of the internet, from the beginning of the internet to 2014, there were 3 billion new users activated online. From 2014 to 2017, so a 3-year period, there were 1 billion users activated. That's a pretty high growth rate compared to before. So we have 4 billion users now online. Does anyone know the population of the world? 7.2? Yeah, that's like 7.5 billion, let's say. So we have 4 billion users online, which means that there are 3.5 billion users that are not yet online. So this is our potential market that's not been tapped yet. So over the course of this past 2 weeks, we've talked a lot about how you can make your apps global, so making sure you're thinking about the world. But the thing to realize is that the world is not just the US, it's not just Europe, it's not just Brazil. There are huge markets out there that haven't even gotten on the internet yet, but will be getting online in the next couple of years. So you should be thinking about how to build for them. So what do we know about these users? Let's look at some data points. I have 4 key stats to share with you. The first is just annual growth over the past year. So if you look at the blue graphic for internet users, there's been a 10% growth since last January. And that connects to 354 million people. And then the green one, which is unique mobile users, it's increased by 5%. These are really, really huge numbers. The second chart is just digital user distribution by region. The boxes I've marked show huge growth rates, but I want to focus on 3 key metrics. The first is just the connection between total population and internet users. So that's the red versus the blue circle. If we look at Western Europe, for example, at the top, right there, we see that the population, which is 6% of the world, versus internet users, which is 9%, is very disparate. But it has less population, but more users on the internet. And if you look at Africa, it's the opposite. It has more population, 16%, versus internet users, 10%. So that's the connection between internet users and population. The next metric I'd like to show is just the connection between mobile users and actual internet users. So if you look at North America, which is a developed country region, the internet users 8% versus mobile users 5%. But in Southeast Asia, for example, or South Asia, the internet users is 16% versus mobile users. So what this tells us is that mobile is really big in these regions. Even though they're less on the internet, they're more focused on mobile. The third key metric here is just volume. So take a look at Africa, Southeast Asia, and East Asia. In total, they represent more than 60% of the world's population. So 16% for Africa, 24% for South Asia, and 22% for East Asia. So that's a huge market already, more than 60% of the world's population. So if you're not developing for them, then you need to really rethink your strategy. The third metric just talks about internet penetration. So right now in South America, 66% of people are on the internet, 29% in Africa. So again, less people on the internet now, but they're likely to come online soon. And then the last one is mobile share of web traffic. So what does this mean? It's really just telling us that the countries on the left, so for example, Nigeria, India, South Africa, for example, they have more percentage of people on the internet there on mobile versus desktop. And on the right-hand side, we see more developed countries, France, Russia, Japan. So for them, there isn't much focus on mobile, at least not compared to just the general internet population. So these metrics, they're all available on hotsuite.com if you want to take a look, and there are more analysis done on them and the insights you can glean from them. So what does this all mean for us? Why should we care about it? Well, if these new users that are going to be coming online are perhaps different from what we've always thought, we need to really understand them so we can meet them where they are. Like Matt talked about at his talk last week, we need to really understand our users, make sure we meet them where they are, make sure that we're solving the problems that they have. So what have we learned about these next billion users? Well, the first thing is they're mostly coming from emerging markets, developing regions. And that comes with a lot of characteristics. So one thing is they're probably on either lower-end devices or less expensive devices, which probably have lower bandwidth, lower memory storage, and probably also lower network capabilities. And then the second big insight, like I said before, is that they're mostly mobile. So now that we understand our users, I'd like to share just some guidelines and best practices on how you can actually build for them and meet them at their point of need. So 6 best practices. I actually decided to add one more, just to throw you guys off a little bit. All right, let's get started. So the first one, mobile data, it's very, very valuable. Mobile data is money, like this cat clearly knows. But really, what does this mean? So if you think about a smartphone, you can have a smartphone, but if it doesn't have data or any kind of connection to the internet, it's essentially a brick. You can't really search for anything. You can't really use it to navigate. You can't use it to find information. You can't use it to talk to friends. So it's useless without data. But the second thing to remember for these regions, these next billion users, is that they most likely have either monthly quotas or they have limited access to data because it costs a lot of money that they might not be able to spend on data. So these are the characteristics. What can we do about this? So one of the things you can do specifically on Android devices is to always know what current network your users are on and optimize your app's performance based on the current network. So one of the really good examples of apps that do this is Google Photos, for example. What they do is they allow users to select how they want to update, sync their photos to the cloud. And so, for example, you can specify to only sync when you're on Wi-Fi versus data. So these are just interesting ways you can think about giving users the ability to customize their app's performance based on the kind of plan or data that they have. The second thing you can do is to monitor network connectivity changes. In different regions of the world, people sometimes have Wi-Fi at home, and then they use data when they're away from their home. But this might not be true for everyone. They might just have the data, and when they move around the city, it connects to different towers, but sometimes the towers might not actually correspond to the data provider that they use. And so you need to make sure that your app understands this reality. And one of the things that Android also provides is a way to actually get notified when your network connectivity changes. So you can use that to also characterize or customize your app behavior. And the third thing, like I mentioned before, is give your users the opportunity to decide how they want to actually use their data within your app. Have them set preferences to either do things on Wi-Fi or mobile. So this is a link just on more information on how to manage your network in your app, but I'll show a quick code example. So this piece of code, what it's doing is it's showing how to actually get information on the type of connection that your user has in their app. So you instantiate a connectivity manager here by just grabbing the connectivity service context, and then it provides different methods to get different kinds of network info. So what you're doing here is you're getting the Wi-Fi connection, if there is one, and you're checking if it's connected. And then you're doing the same thing for mobile and checking if it's connected. And based on the values of these two Booleans, is Wi-Fi con and is mobile con, you can customize your apps to do different kinds of things based on the kind of connection you have. So this is available in Android. So that was all for mobile data. Now we'll move to putting your app on a diet. So what does this mean? It doesn't mean, okay, don't feed your app and don't get it fat, but really think about how the size of your APK affects how people think about your app. So number one, APK size matters. It decides how people think about whether or not to download your app. Some smartphones in NBU countries are, like I said before, low cost, and they may have low memory storage. And so you really want to make sure that you give your users, or you don't give your users the choice of saying, oh, do I need your app or do I need this other app? Make it easy for them to make that decision by not making your app too big. The other thing about having a big app is that your users might stop auto-updates. And this might cause degraded performances and bad review for you if you're not able to get the most recent update of your app. And Google Play Smart App Updates can help with this. So what are some actions you can take on making sure your app APK doesn't grow too big? So what we found is that one of the main reasons for big APK size is just the drawable assets and the resources within your app. So you can make sure, one of the things you can do is to remember to scale assets down rather than up. And so what this means is you can have just one asset that's of very, very high quality and get rid of all of the other levels. So in some apps, you might have different assets for different screen resolution sizes. But what we're suggesting is rather just have the most high quality one and then scale that down for different screen dimensions. The second thing you can do is to use the MIP map directories within Android. And what this does is it automatically sizes and resizes images based on, again, the dimensions of the phone screen. And then you can also use vector graphics, which you can check out later. Another guideline here is to allow apps to do SD card install. So in some countries, in order to avoid having to go to the Play Store and download apps, people could instead share apps with each other via the SD card. So make sure you have that as an option for people in case they want to do that. The third thing is you can remove unused code and resources using the minify enabled and shrink resources in your Gradle file. So this is your gradle.build file. And you can also use ProGuard, which I didn't mention here, but you can use ProGuard within Android Studio. And what it does is it automatically detects which classes, which resources are needed in your app and smartly removes them for you. And finally, some apps have multiple APK versions on the Play Store, depending on either the OS that's running on the user's phone or what kind of screen resolution they have. This is a good way if you want to make sure that each APK isn't too big. So you have one APK per resource type, one APK per OS type. The problem with this option, even though it results in your APK being small, is that you have too many things to manage now. You have to make sure that you update each of them every time you make an update, and you have to make sure that your developers understand which ones are for which users. So again, it has its trade-offs, but it could be useful. So the problem of making your APK small isn't necessarily really just making it small so that users download it easily. It's also allowing more things to fit into the same amount of space. So it allows you to add more features, make updates to the app, and add things that the users might want easily. So one of the ways you can just reduce your app so you can have more features is to use WebP. It's an open source image format. It's developed by Google, and it allows you to essentially compress your images and image resources in your apps, even better than JPGs and PNGs. It's been supported since 4.0, and it really does two things for your app. It makes the APK small, but it also makes your app load faster because your images are now, their load times are now reduced by 30%. And this is very important, not just because it loads faster on 4G and Wi-Fi, but because it loads faster on even lower networks like 2G, which is probably where your MBU users are going to be using this. So we're on the third one. I'm counting down, just so it's easier to go through at the end. But the third principle is smooth like butter. So this really talks about how your app deals with its performance and how it feels to users when they use it. So does anyone know about the Project Butter by Android? Anyone? No? So before 2013, Android had this reputation for being very laggy, being just very low performant, and not very easy to use and not very smooth to use compared to the iPhone. And so there was an initiative to make this better. There was an initiative to make sure that the screen didn't lag and that things moved really fast when users used them. So essentially, one of the things that the team at Google did was to aim for 60 frames per second for all the images. And this is essentially a scientific number created by UX engineers, where they found that images at this particular frames per second worked better for the human eye. The second thing that they did was they tried to reduce not just actual latency, so not just latency within your app, but how users perceived the latency of your app. So these are two very different things, and I'll talk a bit about both of them. So for actual latency, what are the things you can do? You can try to minimize the layout overdraw and layout debt. And what does that mean? So when people sometimes build UIs, they add views on top of each other just because they have a lot of features. So you could end up with a UI that has multiple views such that you can't really very quickly change any of the views for users, for whatever request the user put in. So try to minimize that. The second really important thing is to make sure that your UI thread is only for UI. Don't do any network calls. Don't do any calls to files on your UI thread, because that will just slow everything down and hog the resources. And then the third thing is figure out your memory allocations. Now, if you're allocating memory all the time, maybe you're loading images, you're loading files, you're eating up your device memory. and that's going to cause garbage collections to happen often. But what does this mean, really, for your app? It means that when garbage collection happens, all of your app slows down, because garbage collection takes a lot of computer memory and takes a lot of processing capabilities. So you want to reduce how often garbage collection happens by making sure that you're not allocating too much memory. So before you start to try to improve the performance, make sure you measure it first. So this is something that has come up a lot. How do you measure things? You can use Google Analytics. But specifically for performance, you make sure you profile your code, measure the performance of it. And you can use tools such as System Trace, Hierarchical Viewer, GPU Profiler, and Overview. So Overview is specifically for figuring out how your UI layouts interact with each other. I would also recommend taking a look at Android performance patterns. It's essentially a playlist on YouTube that has a lot of information about what you can do to increase performance, reduce lag, and make the user experience of your app better. So now let's talk about touch latency. So we covered actual latency, the latency that happens because of the things your app is doing. But how can we reduce what the user feels that your app speed is? So latency usually is defined as the time between a cause and effect. So the time between when you do something and when actually something happens because of what you did. And users generally have been found to allow about 100 milliseconds on your app before they start to think that something is wrong. So we definitely don't want to go past that time. So a couple of things you could do for perceived latency. Make sure that every UI action has a visible reaction. So one of the things I've seen that has gone really badly on some apps, especially apps that have forms or apps that take in my bank data, I click submit and then nothing. I don't know if anything is working. I don't know if anything is running. I click submit again, nothing. So you want to make sure that if there's a form or there is something that takes user information, you actually give a reaction immediately. You either have a dialog box, a progress bar, something that says, okay, I got your details, I'm doing something. The other thing is make sure every touchable item has some feedback. So one of the ways to do this is to make sure maybe there are ripples on buttons, because sometimes users don't know things that they can actually touch versus things that are just part of your app layout. So make sure they understand the difference between that. This will really help with how users feel when they use your app. All right, so we're halfway done. Now we're going to talk about some tips for memory. So how do we think about memory usually on an app? There's the memory that your app uses, but remember, your app is not the only app on someone's phone, right? I have Facebook, Instagram, Google Play, everything Google, Gmail, Inbox. But then if one of these apps are actually hogging all the memory, then all of the other apps can't function. So you have to think about how your app uses memory and how it affects the memory of other apps. So be a good citizen, essentially. So really, what's happening here? So sometimes, if you have an app that uses a lot of memory, it means that the other apps don't have the memory on the phone to use, so they can't cache requests or cache responses. And so each request to the other apps has to go through the network or go through storage. And this makes all the other apps slow while making your app slow. But now users, actually, if I go back, in this figure, in the screenshot here, users can actually see the processing stats of all your apps. So you have to make sure that your app isn't one of these top ones here. So what can you do? There are some built-in functions in Android that can help you with this. So one of that is using the intent service class rather than service for any of your app processing. And what this does is intent service has a built-in mechanism to actually do some garbage collection once it's done with any sort of memory allocation. So you definitely want to be using that. The other thing is to make sure that your app recognizes what kind of device it's installed on. And one of the really good ways to do that is to use the activity manager method called isLowRAM device. So you can use this to customize how your app behaves. And for example, you can allocate a smaller amount of memory if you're on a low RAM device versus otherwise. The third option or action you can take is to use on-stream callbacks. So what does this do? This is essentially a way for you to keep track of how much memory is available on the device. So as you're doing some processing in your app, you can use this callback to figure out how much memory is available on your device. And if you're getting to a point where there's low amount of memory available, you can use this callback to decide to garbage collect or release some memory. And then finally, you can use process stats and the new memory monitor to figure out what your app is actually doing and see ways that you can improve. This is available in Android Studio. So this is what the memory monitor looks like, and you can use it to profile your app. So a huge memory problem actually comes from bitmaps, from handling huge bitmaps in your app. And a couple of ways that you can do this effectively, so rather than using a huge bitmap, is to make sure that your resizing of your images actually happens on the server side. I've seen apps where this happens on the client side, and it's impossible to handle, because if you're doing all of this on your client side, then your client side actually allocates the memory for the full size of the image rather than the compressed version, which is what you want. So make sure you're doing any bitmap manipulation on the server side. Also, within your app, you can resize and reuse, use memory caches, do resource pooling, network resource pooling, and so on. So this would really impact how much your app and your client side actually has to allocate memory for. You can also use vector drawables, or you can use Glide. I'll talk about these in a little bit more time. So Glide, it's a simple and easy to use interface for media, that's images, video, and coding. And what it provides is, it's an open source solution for providing memory and disk caching for images. And it also does resource pooling. So it makes sure that all of the images it needs to get are pulled into one request and done at the same time. You can find out more information on GitHub about this. So to use Glide, it's really just adding a simple dependency in your Gradle file. You use the bump.glide dependency, this one here. And then in your main activity, you just need to find the view that you want to use Glide on, and then load it into the image view. So it's really like less than 5 lines. But what this allows you to do again is to do memory and disk caching of your images. So 2 more left. Now we'll talk about battery, and the final one is architecture, so battery. So you definitely don't want a situation like this because someone is trying to use your app. Really, you should think about the 3 main consumers of battery in apps. It's usually the screen, the mobile network, and if your app prevents people from going into low battery mode. So like I mentioned before, users can profile your app and see how much it either contributes towards memory use, like I said before, or battery use. So you don't want to be in a situation where people have to uninstall your app just because it's taking up too much memory or battery. So what are the things we can do? So the first recommendation is just don't use wake locks directly. Wake locks are ways for you to keep your screen active. So situations you want to do this are maybe if your app plays a video or is a streaming app and so on. So you definitely want the screen to be active. And this is situations where people will use a wake lock. But Android recommends using the flag keep screen on flag, or using a receiver, because then these receivers and Android is responsible for making sure that the locks are closed once it's done. So making sure that the lock is released. If you use the wake lock, you yourself, you have to be responsible for making sure that it's closed or it's retrieved when it's done. The second thing you can do is allow the system to wake you when it needs to hold a screen lock. So one of the things people do is to use GCM or the alarm manager to get notified about what point in the app people need to have the screen on, and then only at that time do you need to get these locks. And then the third thing is to use the job scheduler API. So what this does is to schedule similar kinds of jobs into the same batch and use this. It uses essentially the job scheduler to make one network call rather than making several network calls. So essentially how this helps the battery is it prevents multiple network calls that could potentially kill your battery. And I'll show some examples of this. So this is the battery historian. You can use this to profile your app and see how exactly or where exactly battery is getting, or your battery is being drained by your app. And it's a simple command, adb shell dumsys battery stats. So one of the ways also you can improve battery usage by your app is to prefetch your content. So anticipate what users are probably going to do next so that you don't need to make multiple calls either to a file or to the network. So why is this important? Now, for the radio, which connects to the network, there are 3 states. There's the radio standby, which is great. No battery is lost there. And then there's the low power and the full power mode. At the low and full power, that's where a lot of your battery gets drained. So what you really want is for your app to be at this part for most of the time. So what happens here? For when your radio is in full power, this is maybe it's talking to the network to get something. It takes about 5 seconds for it to become low power, and then for 12 seconds for it to be in standby. So this is a really long time for it to get here. But sometimes what happens is after you make a network request, it's in full power, and then it's idle, it goes to low power, but then you immediately make another network request, and it goes back to full power. So it just stays in this loop where battery is draining all the time. You want to be able to make sure that this loop only happens maybe a few times, and it immediately goes back to standby, where you're not draining any battery. So what does that mean for us as developers? It means you want to batch smaller requests together and make only one call to the network. You don't want a situation where you're making frequent calls and keeping your app in this power draining loop. So a question for you. Based on that explanation, what do you think is better for your app to do? Fewer large downloads or many small downloads? Many small? Fewer large? Who thinks fewer large? Okay. Who thinks many small? Ah, okay. I did not do a good job of explaining this. All right, let's go back. So, this is a good state. This is where you want to be. There's very little battery draining at that stage. This is the worst drainage happening here. Now, whenever you make any call to the network to download something, to get a file, you're at full power. When you're at full power, you have to go through low power, and then finally, before you get to standby. And it takes you 17 seconds to do that loop. But let's say you do a call to the network, you go to low power, and then immediately you do another download. And you're back here. And you do another download. You're in this loop forever. And what does that mean? You're at the loop where you're draining the most battery. Duani?
But is there any risk that if you're doing fewer large downloads,
That's a really, really, really good question. So, sure. So Duani asked is there a risk that if you're doing fewer large downloads, it might not work because low connectivity, you're in low connectivity countries. So that's a really good question because what I said before is in NBU markets, sometimes one of the issues that's predominant there is that there's low connectivity. So one thing that your app can do is to balance this. And how can you do that? You have to make sure that your app is able to behave correctly, even though the large downloads can't complete. So the first thing you need to do is to make sure you have caching in place. So you can do smaller downloads, and if it's not cached, then you can pull things together and do the fewer large downloads. So that's one thing. Caching is definitely very important, and I'll actually touch on this later. But then the second thing is just to make sure that your app, even though it can actually download the information that's needed, it can actually degrade in a way that doesn't degrade the quality of your app. So if you ask for something from the network and it's not available yet, it can give you a notification that it's not available, but it will be available as soon as possible. So make sure that your app recognizes what it does and can provide a good UX, a user experience, even though it can't get the data from the network. So back here, the answer was not many small downloads, but fewer large downloads. But again, caching will be very important to make sure that even though you do have smaller downloads that have happened successfully in the past, you can make use of that and not have to wait for the fewer large downloads. So the final thing is architecture. So this is what ties your app together. And it's very general, but it actually makes a big difference. If you architect your app in a way that's not, actually relevant for your users. So what does this mean for NBUs? So you want to really optimize for fast and responsive user experience and user interface that's not really tied to how the network itself performs. So this relates a little bit to the question Dewani asked. So you want to make sure that your UI is fast and responsive regardless of what the network gives or doesn't give it back. So 3 ways you can do this is to ensure that identical network requests are never duplicated. So in some countries, we don't have to worry about this. We can make several calls to the network and we'll be fine, either to the local database or to the network itself. So what you want to do here is to make sure you have a local cache that holds most of the frequent requests that the user has made. This way you reduce how often you actually have to go over the network and get data. So the second thing is that you need to make sure that your screen is navigable, even though there's no data available or there's no Wi-Fi. Make sure that there's some basic tasks that the user can do, and make sure that it's clear what they cannot do if there's no data or Wi-Fi available. And the third thing is, never block the UI if there's an operation that takes a long time. Make sure that there are visual cues that something is happening, because sometimes you'll be using an app and you try to do something, maybe you try to download a file, and it's downloading in the background, but all of a sudden you can't scroll anymore, you can't do anything. It's just stuck there. And the user can't tell that anything is happening. So make sure maybe you have inline scrolling spinners or something to tell the user, okay, something is happening, but I can't process any further requests right now. So here is an example architecture you can use. You can separate the user interface from the actual content providing. So what does this mean? So here I have a content provider or manager, essentially that splits my local database between requests to the network. So what this could be some local storage on the device that handles frequently made requests. So if it's like a cache or some sort of memory storage. So if there's a request from the UI, from the user, it comes through the loader, and if there's a cache hit, the result is just returned to the user from the database back to the interface. And then if the request is not in the cache, then it goes through the sync adapter to the network. So in this way, you separate the actual UI from the network, and it makes your UI experience a much easier experience for the user. You can find more information about this specific architecture design at this GitHub link. So some other architecture design guidelines. One of the things that Google has espoused for a very long time is the use of material design. And there are a lot of extensive guidelines on how to design your app, how the touch and feel should be. And the idea there is because Google and some other companies are using material design, it's really easy for your users to intuitively know how your app works. Because users are now very familiar with what a card is, what a floating action button is, what the different widgets do. And so if your apps follow that guideline, then you get the previous knowledge that the users have. So it might be worth checking out how to adapt material design to your apps. All right, so we've gone through the 6 guidelines. Does anyone remember all of them? Anyone want to try? Anyone remember the last one? No? All right, so the last one we talked about was app architecture, so how your app works together, how the UI works with the network, and how you make sure that the user experience doesn't degrade based on what the network does. Second thing is battery. Make sure your app isn't hugging battery. The third is memory. Make sure your app is a good citizen. Make sure it works well on its own, but also in relation to other apps. Make sure the performance and the user experience is great. Make sure it doesn't lag. Put your APK on a diet. Make sure it's not too big, such that people can't even download it. And then finally, just don't use too much data. Understand what kind of network your users are on, and make sure that you customize your application behavior based on all those details. So that's all from me. If you have any questions, I'll take them now. Thank you. All right.
Hello. Oh, okay, I was working. I would like to know a bit about the trade-off between the storage that you use versus the data. So to give you a specific example, we work with maps and algorithms, so we prefer to leave the heavy calculation on the server, so we don't force too much on the storage. But we think about going offline because then we can solve the problem of the data. So what do you think about this trade-off between data usage and storage?
So I think one of the things I touched upon very briefly is if it's possible to customize based on the actual device you're on, that would be a great starting point, because some devices, might have a lot of storage, a lot of memory, and so you can store more things locally then. So it'll be very interesting to see if you can make that customization within your app, where in some cases you can actually do some more local storing, and in other cases you can do some stuff on the network. At the very back.
Hi, Onome. Thanks so much for the last 2 weeks. Amazing stuff we learned here.
Thanks for having us.
Thank you. My question is about Android has increased a lot of permission requests for users during the app process. It could compromise the user experience during the usage of the app. A long-term vision, how it could compromise some apps, considering that Apple today is very close to the operation system, and our user experience with your app is totally terrible, and it's very great with Android. But we are seeing that Android has evolving about security and requesting a lot of permissions for users during the real-time execution of the app. Could you share something about this?
Of course. So I'm not on the Android team, so I can't speak specifically to that point. It's a very, very good point, though. I mean, when I download some apps, it asks me for permissions for my contacts, which it doesn't even need access to, for example. So it's a great question, but one that I'm not qualified to answer right now. But I would say that thinking about still the difference that exists between Android and iOS, because Android is still open source, it allows a lot more flexibility than I think iOS will ever allow. But as far as the trend, yeah, it's yet to be seen what actually happens there. Any other questions? All right, great. So make sure if you're interested to see more and just to learn more about how to use this in an actual coding scenario, to check out the information and all the links I shared. And if you weren't able to capture them, just email me and I'll send them to you. Thank you.